Alright, so for section 4.9, we want to talk about what is called the antiderivative. So a function f, a capital F, is said to be an antiderivative of a function little f on an interval I if the derivative of capital F is equal to little f on I. So intuitively, what you want to think about this is that you want to think that this is the inverse of taking a derivative. So what is the antiderivative of x? We are essentially asking what is the function capital F so that f prime is x. What function can we take the derivative of so that the derivative is actually just x? Since x is a linear function, a good guess would be that f is equal to x squared. But what happens when we take the derivative of f? We have that f prime is equal to 2x. This is not x, because of the 2 in front. So how can we make it x? Well, we want to get rid of the 2, so let's try to multiply by some constant to take the 2 away. In this case, the constant is going to be 1/2. So if we add a 1/2 in front, we indeed get x. What this means is that our big F have to be 1/2 x squared. So when we take the derivative, we have 1/2, we bring down the 2, we subtract 1 from the exponent, which is indeed just x. Since the derivative of f is equal to x, which is little f, we say that 1/2 x squared is an antiderivative of x. Here, I want to note that this is an antiderivative, meaning it's not unique. Let's ask ourselves, what other function can we take the derivative of to still give us x? Well, if we take a look, if f is equal to 1/2 x squared plus 1, what happens when we take the derivative? We have f prime is equal to still just x because the derivative of 1 is 0. This, by definition, means that 1/2x squared plus 1 is also an antiderivative of x. And the same goes for any other constant that you might add to 1/2 x squared. The derivative in this case is still going to be just x. And that's still going to imply by definition that 1/2x squared plus 3 is also an antiderivative of x. All of this discussion amounts to the following theorem. The theorem states that if f is an antiderivative of little f on an interval I, then the most general antiderivative of little f on I is going to be capital F plus c, where c is a constant. As seen in the previous example, whenever we take the derivative of a constant, it becomes 0. So when we go the opposite direction, we don't know whether a constant exists or what the value of that constant might be. So do keep this in mind, that whenever you try to find the antiderivative, there is some constant that you must write down. And this is the most general antiderivative.